All right, class, let's go with it here. So 10.4 hyperbolas, last lecture of new material in this class. Ooh, it says that I want to leave. I don't want to leave. Try this again. Okay. Okay, let's jam with this guy here. 10.4 is where we're at. And let's one more time kind of looking at this stuff here. What are these conic sections all about? Is the fact that I can graph each of these based upon two cones that are touching each other at a corner. That's kind of what this is all. That's why they're called conic sections, because they're cone sections, or cones of sections of cones. So a circle is really just, whoa, come on. A circle is really just one of those cones sliced exactly perfectly, what is it, horizontally. An ellipse is really just a slice of a cone in a diagonal shape. A parabola, a perfect parabola, is a slice of a cone that's exactly in pace with the side of the cone as well. And then a hyperbola, which we're going to cover today, is a plane cut that actually hits both cones at the same time, right there. So it's this little usually symmetrical. They're always going to be symmetrical, yeah. Okay. So let's jam. They get complicated as far as formulas go, but other than that, it's cool. Okay, so I'm going to check for time wise. 1, 2, 3, 4. I got 4, 5, 4. I skipped number 5 now. Let's see if it's in here somewhere. Okay, let's jam with it here. So what does a hyperbola look like, first of all? Don't need to write this down. Let's see. Probably don't need to write this down yet. We'll get to the formula section, but just want to get you guys, this is a horizontal parabola. It's kind of like an ellipse, if you think about it, but it's almost like cut and facing the other way, right? Remember ellipses were like this, with the foci right here. In my mind, it's almost like the hyperbola is like this, whoa. It's this cut of it, like this, come on. And then it's just facing the other way. So it's facing the opposite way. It's going away now from instead of being together, it goes the other way. Okay, that's what it looks like. Let's see, a few things here. Notice just like the ellipse, the addition, oh no, hold on, look at this. It's not addition, subtraction now. So it's D2 minus D1 is going to be a positive constant. So it's subtraction between the foci. And then we have, we call this a transverse axis. So we do have a center that we're going to graph just for the sake of graphing it, and then we're going to do that. So then the A value is the distance from the center to the vertex. The C value is the distance from the center to the foci. That's kind of what we're looking at right there. We'll get into a few things here, then we can start. We got to get to the equation first here, so it'll be a little while here just to get to the equation. All right. Okay.
So I'm just trying to think. So what is D1 and D2 in this case?
D2 is the length from the focus to the other line.
Okay. And then so,
and then
so
D1
two foci, and then D1 is like a point on one of the.
D1 is, let's see, the measurement from the foci to a point on line the closest.
Okay.
Because we could go the other way too. We could go this way. We could go like this as well, right? And that would be a change. So it's the other to the other graph, to the other side of the graph.
Okay. That is
No.
a good question.
Shut up, you're not allowed to be on this side. You might not be wrong.
Oh, those are just the terms of the other one. Okay.
What's happening to me?
Okay, we're good? We're gonna write down a few things here, but let's get to the formula. But before we get to the formula, I just want to show you guys the graphs. So this guy is called a horizontal hyperbola. We good? That's a horizontal hyperbola because our axis of our transverse axis of transversal, I guess you could do that too, is coming across horizontally. We good? All right, let's show both of them and then we'll get to the formulas here. So next slide, you don't need to write down or graph the next slide. The slide after that, that's when we want to get to the equations here. So this one right here, just to show you. Transverse axis is horizontal, just like we said on the other one. And then you can also have this one. You can have a transverse axis that is vertical right here. So there's two different pieces there. And then what also might have done between the two here, that's general, right? This is now a graph including H now. Hey, remember those guys with the ellipses? Remember that, H and K? So H and K is a center in both times. To get to the foci, we add a C value to the center, which makes sense, depending on that right there. Okay, we're good? Let's get to our equation here. This is the one you want to write down. So standard equation of hyperbolas, here we go. The transverse axis is horizontal. So it's written as x minus h to the second power over a squared minus y minus x to the second power over b squared is equal to 1. Hey, just like the ellipse, they're both equal to 1 again.
The only difference
Oh.
that they're both squared.
Now the difference is that it's subtracting versus adding.
Ah, good, good. Okay, look back. This is what I had on the next slide. The next slide was like this right here. Yep. So let's write down the equations first, and after that, we'll see if we compare them to the ellipse formula. That's the next slide. That's cool, cool.
On the last ones, you switched. I mean, I know it's the same thing. It's just you wrote them differently in the way that
Yeah.
you switched
So
the tops this time instead of the denominator.
let's see. I have both of them written. It's kind of like smaller font here. So this is the ellipse formula right here. I know it's kind of smaller here. So the difference between the two, what do you guys say?
I cannot help you.
It's too small.
Yeah.
Okay, so first things first is there's a minus sign instead of a plus sign. We good? So this one for me. So got this look here. That's one thing that has changed. Whoa, come on, come on, come on. They're trying to make me do a. Okay. So first thing that's changed is the minus sign. Second thing that's changed is notice on the ellipses, if you guys look back to your ellipse formulas, we never switched the x's and the y's. The x's are always here, and the change was which one's bigger. It was A bigger than B, right? I think we had it. You guys talk to me. Look up your ellipse formula. How was it? Was it A is less than B or B is less than A? Which one was the bigger one? They determine if it's horizontal or vertical.
So A is bigger than B.
A was over here, B is over here.
Oh yes, no. Oh yeah.
Right?
Yeah.
Is that the way it was? Okay, so this in the hyperbola, we don't care about that anymore. We care about where the negative sign is, and then notice real quick here. Notice in the front, sometimes it's X, sometimes it's Y. That's so the position is the important part here. So I always think of it this way here. If X, whatever's in front, X is in front, therefore it's the horizontal one. The Y is in front, it's the vertical one. We good? So it's the equation in front that's positive. Okay, everything else remains the same though with it. Then how we graph it's going to be a little different too. Okay, let's jam because we have just limited time here. So you can tell if it's horizontal, X is in front, vertical, X is, Y is in front. Okay, and then talk to me if anybody has.
So are the bottom equations for the same reason as we had them for the ellipses?
Yeah, this is just in standard form. This is off of the, so it's zero origin, yeah. Off the origin, same exact stuff, just in the origin. And it also gives you the equation to C. C is the unit measure to the, so that's the same as the ellipse. Is it the same? Let me check real
No,
quick here.
it's not. It's for minus b squared.
That's right, yeah. So on ellipses, it was a squared minus b squared. This time is a squared plus b squared. Thank you so much.
So c squared equals a squared plus b squared is, okay, got it.
All right, we good? Let's go with it. Isabel, you're writing in your notebook now. Ah, markers are gone. Shucks. So find the standard form of an equation of a hyperbola with foci is -1, 2, 5, 2, and the vertices are 0, 2, 4, 2. So just to draw it out, just let me see some kind of connection here. Let's see. I'm gonna go like this. Let's see. It is not on the X or Y coordinate system. Foci is at -1, 1, 2. Here's my foci. And then at 5. So 1, 2, 3, 4, 5. 5, 2. So there's my foci there. So because of that, I know it's horizontal. Everybody agreed there? Horizontal. The vertices are at 0, 2. That's cool. And 4, 2. So now I know how to graph this guy. The graph is kind of like this right here. This way and this way. Next question is, I think I know this. What's the center? Two comma 2. I am going to agree with Isabel here. It is 2, 2. That's cool. Okay, I got a few parts here of my hyperbola. Which one's first, the X or the Y?
I'm just asking if okay.
Mm-hmm.
X.
X is first. It's horizontal. Awesome. So I have myself, let's see we can start this. X minus 2 to the second power over something. I don't know what that something is. Minus Y minus 2 squared over something equals something, or over something is equal to 1. That's what I know so far.
Well, how do we know the center aside from counting?
How do we know the center?
Like, did you just count? Find it?
Yeah, I just counted. Or,
Is there an actual way to do it?
sure, yeah. Algebraically is we get the
Subtract the X
midpoint. Remember midpoint? It's the midpoint of the foci lengths. Or it's the midpoint of the center lengths, whichever one you want. Okay, next is, I also, what we can get from this is the A value. Remember, the A value is from here, it's horizontal, right? So the A value is from here to here. That's cool. Everybody okay with just 2 for the A value? So this is, let me label it here. That's A value. And then from here to here, that's the C value.
A value is to the vertices and C value is to the foci.
Uh-huh.
The C has to be 3.
C is 3, perfect. But C is not part of a formula, huh? Bunker. Okay. A is part of a formula, though.
It's from the C squared equals A squared.
Yes, it connects our A and B and C together. That's what it does. But for the A value, you guys okay with putting A value as 2? Is that right?
Yeah, A value is 2.
Therefore, A squared is going to be 4. So I'm going to go with 4 right over here. Good there.
Then you can do 3 squared equals 2 squared plus 2 squared.
Awesome. Yep. And then we have C squared is equal to
3 squared, which is 9.
it's A squared plus B squared, right?
Yeah.
Okay, B squared. So I'm going to plug in 3 here. Squared is equal to 2 squared should be added to B squared.
And what does the C value tell us?
The C value is the length from the center to the foci.
Either foci, doesn't matter.
Either foci, because they're going to be the same exact distance.
Right.
So 9 is equal to 4 plus B squared.
So
Oh.
B is equal to the
Square is
square
5.
root of 5, yeah.
But since it's B squared, B is just 5.
Oh, that's right. Yeah. So we
Right.
don't even need to do the square. That's cool. I could just put in the 5.
So wait,
5 goes in right.
K?
H and K is the center. It's this guy right here.
Wait, I can't remember. Why are we allowed to just get rid of the square root? I always forget this.
Yeah, because the
B
form.
equals 5 and it's over B squared. So 5 root 5 squared is 5.
Right. Oh yeah, you can just plug it in because it's 5 equals B squared and then, okay. You
Yeah,
don't need B by itself.
correct. Sweet. Okay, guys, that's awesome. Let's go with it here. Another piece of the puzzle here. There's a graph of it right there if you like. And sometimes they put the 2 squared in there. Sometimes it's just a 4, just kind of depending. It's not completely standardized that you have
So
to.
that
do it that way.
equation is our answer.
Yes, it says find the equation of that hyperbola. We just found it based upon where the foci were and the vertices were.
Cool, cool.
Has a lot of application of stuff. How sound works, how a microphone comes and takes sound in. It goes to there's certain orbits of things that pass up in our meteorites would be something. Meteorites have a hyperbolic, they come past us, right? And they go on and they keep on going. And that's a type of hyperbolic going through space. Okay, let's jam here. Let's see. Next thing, we're going to put one more piece on it here is, oh boy, this is a big one here. Hyperbolas have something called asymptotes.
Oh,
So notice that as this value goes out, let me change it to black here. As this graph goes out, this graph line gets closer and closer and closer to this little asymptote right here.
That wasn't so bad.
Okay, so now we got to think about this here. If the hyperbola is a horizontal transverse axis hyperbola or a vertical, now notice what's the only change here. Absolutely. So it's the
When it says plus or minus, does that mean there's going to be 2 separate equations?
2, yeah. So we have asymptote going diagonally right, The asymptote going diagonally left.
So there'll be 4 equations then?
No.
No, 2 equations with a little plus and minus here.
Like, is there gonna be 4 in total? Or
Oh, no, two equations because it makes 2 lines, right? Now there is like a quick way to do the asymptotes. And notice that right over here has this little box right over here. It's the distance to the vertex here. Then you also need to know your B value going up, and you make a box between the A and the B values. And that's probably easier to do than the formula, especially if you're just graphing here. So notice we make this little box right here, and the corners become our asymptote points. Good there. So sometimes ask for an equation of it, sometimes ask for just the So let's go for it. Let's do one drawing here. I think that's what we'll have time for. Can we sketch a hyperbola? That's what we want to do. Let me just check on the homework here. Yeah, okay, we covered that. We covered that. Yep, okay, we're good there. We're gonna find all these pieces here. So with this one, we should be able to get the homework done here. Okay, let's go with it here. So let's see, it's always said equal to 1. So let's divide by 16 everywhere. And we should get ourselves x squared over 4 minus y squared over 16 is equal to 1. Are we good there? All right. Horizontal or vertical? That's what we need to know.
What did you write underneath the equation?
16. I did everything by 16 to get a 1. Said equal to 1. Okay, so off to the side here, tell me if you agree with here. H and K. I know that H and K is equal to 0, 0, right? We're at the origin at this point. So boom, I'm gonna start my graph here. My center is gonna be here, even though, again, that's not part of my graph, right? That's just kind of getting things set up here. Horizontal or vertical hyperbola? You guys say horizontal or vertical hyperbola? I go with that. Horizontal is what we have here. And let's see, we have about 7 minutes here. So I'm going to try to put this all together here. So I think what's happening here is this is my A squared. Right, that's my B squared. So A technically is equal to 2. That's when I need my A values. B is equal to 4. Okay, so let's keep that in mind. So I'm going to go out 1, 2, and put a little dot there. I'm going to go out 1, 2, put a dot over here. So that's going to be my vertices, right? Then I'm going to go out 1, 2, 3, 4, put a dot there. Then we're going to go 1, 2, 3, 4, put a dot down there. That's my B values. Good there? As far as drawing the hyperbola, as far as drawing it already, we'll do that in just a bit here.
How do you know dots?
The A value tells me how far I am away in either direction to the vertex.
Okay. And the B value is still the same thing, but for vertical?
Yes, The B value is the vertical piece there to it. And then I needed my C value because that's going to determine my foci. So tell me where my foci are. Actually, we need to list all these down because on the homework, it makes you list all these down. So vertex is at -2. 0, and positive 2, 0. Okay, foci, let's do that. Where's our foci?
So why is the vertex only -2 and 2 and not also 4, -4?
Because we have ourselves a horizontal hyperbola.
How do we know that's horizontal?
Because the x goes first.
Oh, if it were y squared minus x squared, then you'd be vertical.
Okay, now I need my c values, I believe here. Let's see, c values are, it's c squared is equal to a squared plus b squared, is that right? So in this case, 4 plus 16, is that 20? And c value would be about 2√5, right? Anybody in your calculator, just real quick here, what's 2√5?
4.47.
Okay, so 1, 2, whoa. 1, 2, 3, 4, 4.47?
Yeah.
So about 4.5? Okay, so 1, 2, 3, 4, 4, that's 5. So the vertex, the foci is right here. Wow, so this is a very 1, 2, 3, 4, 5. So there's my foci. Okay, so my foci are going to be at, and we want to give the exact form here. So this would be 2√50 and negative 2√50. It doesn't matter which one goes first, the negative or the positive, but we got those. Okay, I got center. And if you want to put center over here, that too, that's fine. Center. Center is 0, 0. My vertex is at -2, 2. Foci is that right there. Think we're good. Anything else we need here? Asymptotes. Okay, so let's go with this here. So the easy way to do the asymptotes is you connect the corners of your A and B values. You good? So go like this, connect them in the corners, connect this in the corners. There's my and almost there. Then we're going to put dashed line through the corners. It's going to go like this, and put your dashed line through. It has to go through the corners, and since the center is at 0, 0, it has to go through the center. So it has to go center and corners all the way through. There's my first line. There's my second line right here.
You really need to know the asymptote equation.
Yes, at the end. On the homework, yes, you're going to be required to give me the asymptote. Yeah, and the equations for asymptotes. Okay, so we're ready to graph it, and then we'll find the equation for asymptote in just a minute and a half here. So if you're going to do this here, here it is. You're going to draw this line very close to the asymptote on one side, and then you lean out towards the other, and kind of try to make them uniform here. This one, same thing here. Etch it right, super close to the hyperbola. Come off of the asymptote, turn, and then come right back to the asymptote on the bottom. Boom, we've done it. Okay, real quick here, let's get our values for our asymptotes here, our equations here. Y is equal to, and I'm going to turn my page to the formulas right here. It's a horizontal hyperbola, is that right? So it's K, which is 0, plus or minus my B value, 4. A value is 2, and it's X minus H, which is 0 anyways. Oh, that's so cool. So here it is, plus or minus 2X. So then my two asymptote equations are, and let's put them down here. Asymptote ASY is
Look at all these numbers on top.
Uh-huh. It is from the previous slide. It's this little piece right here. It's K plus or minus B over A X minus H. It's that little formula right there. It is not bad once you see it, once you have delineated all the numbers here. Dylan, talk to me here. We got a 0 because K is 0 because our center is at 0. H is going to be 0. And the B is coming off of right here. And the A is coming off of right here. So I just need to know 4 numbers. So K is equal to 0 plus or minus. It's 4 over 2, which is just 2x. And it's x minus h, which is just 0 for h. So the two equations, we need to write them separately though, because they're 2 different equations. So y is equal to 2x and y is equal to negative 2x. Those are my equations. We're a little past time, but that is it right there. There's your graphing of the hyperbola. On the homework, that's what you have. You have,
Are we turning in our test questions?
yes, please, turn in test corrections if you want to get credit. Like Camille does not want to get credit, so she's not going to get them in.
We can test?
Yes, please, just right over here.
Do you want to